Today we'll learn about the transactional annotation in Spring Boot with a practical example. So let's directly jump into the tutorial. So this transactional annotation is actually annotation in Spring Boot which is used at method level to tell that all the operation inside that method should either execute it together or should not be executed at all. That means if you do multiple database operation, let's say insertion inside a method, and there are some exception after executing one operation, then everything will be rollback, and only if all the operation executed successfully, then it will be committed to the database. Okay, so there are lots of scenario in software development when we are working with a application requires this kind of scenario. One of the example is balance transfer. So when you're transferring balance to a friend, and if an exceptions occur after detecting the balance from your account and is not credited to your friend, then the full operation is partially complete and it will result in inconsistency in the database, right? It will be deducted from your account, but your friend will not get the amount credited. So in our application, we have one scenario which I'll be using to explain the transactional in this tutorial, which is updating the task. So when updating a task, we have two operations. One is update the existing task, and then we also want to insert the log of the update in log table. Okay, so here we have two parts. In the first one, we are updating the existing task, and then we are saving the log. So our purpose is here to make sure either both operation complete successfully or none are. So if some exceptions occur after updating the existing task and before executing the log insertion, the task update will be rolled back and will not reflect to the database. So for that, Spring Boot provide us the annotation, the transactional annotation. So it is very easy to achieve our requirement. We just need to annotate the method with @transactional, which comes from springframework.transaction.annotation. Okay, so now our purpose is fulfilled, but there are some important things about transaction we need to know so that we can understand what is going on behind the scene and we can control our transaction as we want. So let's first understand how Spring Boot achieved this transactional thing. Spring Boot actually use AOP and dynamic proxy to control the transaction at runtime. So when a method is annotated with @transactional, Spring Boot implement a proxy of this method which controls this method's code. Let's first understand how we can have more control over our transaction. There is an issue with this proxy-based implementation of transaction in Spring Boot. I'll explain that at the end of this tutorial, so stick up to that. So first, let's understand the different type of parameter this annotation take. The first parameter it takes is propagation, as you can see here, then isolation, and then timeout, and if the transaction is read-only, and some other parameter like rollback class, transaction manager, etc. So first let's see what is propagation. So if I type propagation, it have few values, which is mandatory, nested, never, required, supports, etc. So this propagation actually controls how that will behave. So this can actually handle the line database transactions. So when we are working with an application and we need to do certain thing transactionally, we can provide some additional parameter, like let's say in a scenario where we have three operation, first two has to be transactional, but the third one is actually optional. If it fails, then we do not have to worry about that. But if the first two of the operation fails, then we need to revert that. So in that case, we can implement a method inside the main transactional method with a parameter called nested. And another option is support. That means when the method is being executed, if there is an existing transaction, Spring will use that. If there is no transaction found, then it will execute without any transaction. That means it will not guarantee that things are transactional. And we have got the idea how we can control the transaction with this propagation. So in most cases, we can achieve our requirement, our transactional, without any parameter. So we have got the idea what is propagation. Another thing is isolation level. So here for this isolation, we have few parameter, which is read committed, read uncommitted, serializable, and repeatable read. This is also useful for a special kind of scenario when we need to handle some scenario like dirty read, phantom read, etc. Okay, let's say a scenario where a few rows are accessed and updated in multiple transactions. Okay, so isolation level actually controls the isolation level for the ongoing transactions. So let's say there are multiple transactions is operating in the database at the same time, then there are some uncommitted changes in other transactions. Should we have access to those uncommitted transactions, or should we only read the committed data? So by default, here the default level is read committed, this one, but in some scenario where we want to read uncommitted, then we can use this one. So this thing actually works along with the underlying database. Spring Boot Transactional API actually provide the full abstraction to work with any database, but for your specific requirement, you also have to check if your underlying database handles this or what are the constraints. Okay, so we have got some basic idea how the isolation and propagation can control our transaction. So for isolation, the default value is read committed. For propagation, the default value is required. This means support the current transaction, and if no transaction exists, it create a new one and continue. So this is a standard scenario for most of the transactional work. Okay, so once you have knowledge of thing like data read, phantom read, and the propagation level of your transaction, you have more confidence on your development, and you know how the application will behave in scenarios where a high number of transactions runs concurrently. Okay, so another parameter, important parameter, is read only. So if you do not write anything, only reads with multiple query, then if we use this read only annotation, then all read operation is executed in a single transaction, which minimizes the pressure at database server because only one transaction is executed. So in that case, it is very helpful. It is an optimized way to all the database select query executed in a single transaction. So you can also learn more about this. Okay, so this is how you can have more control over your transaction. So let's now see the one disadvantage that comes with this annotation. So this transactional annotation is very crucial. It is being used in Java Spring applications from the beginning, and it is actually a standard approach. No complaint about this. It is a very good implementation, but one thing about the internal implementation is, as we have mentioned earlier, it uses the proxy-based implementation, which actually implemented in runtime. Means this method is wrapped up in other dynamic implementation which controls the transaction for this method. So the problem with this proxy-based implementation is when you call this method from another method within the same class, then that proxy is bypassed. So that time it is not executed transactionally. Okay. So if I call this method from, let's say, from this controller, then the proxy implementation of this update task method is actually called, since this method have transactional annotation. But when we call this method from another method of this task service IMPL, then that proxy is not used. So we have to keep that in mind, that transactional annotation uses the proxy based implementation. And if we need that kind of scenario, we can also achieve that. We have to follow some strategy to achieve that. But apart from that, transactional annotation is very crucial, and it have a great implementation in Spring Boot to work with. And so I hope you got the idea what is the transactional annotation, and I'm interested in learning how you uses this transaction, if you ever used any propagation isolation level or any other parameter along with this annotation to achieve your requirement. So feel free to comment your feedback